Okay, looks like we're up and running.
Yeah, I think I got a request for a little e to the x work. So thinking about that, I actually am going to do 3 problems, actually 4, but 3 of the same type. And I'm hoping that, you can try them yourself before I do them, but then you can follow along. And then maybe the second one, you might learn something from the process and then try it again on your own. Same thing with the third, and we'll try to standardize the approach and layer this video with some discussion to take us a little bit deeper into what's going on, give us a little better understanding of the process. So I am going to do an estimate for this answer. All right, I'm going to find an estimate for x, and I'm going to do it graphically first. And so I'm going to do 3 just like this, then a slightly different e to the x problem. And it's probably new for you to try to do this, but we really have 2 graphs here. We have the graph y equals 2e to the x minus 4 over 5 plus 7, and we have y equals 19. So we want to know when they equal each other, so we're going to put them on the same graph. So I'm going to graph the left side of this equation, which is exponential growth. E to a positive x is exponential growth. And what we've been doing in class is making it a 3-to-1 ratio. So if that's the first coordinate right there, then 3 times it would be maybe that's 3 times, might be a little further over. All right, so I'm going to actually start again, and I'm going to use the ruler, which in this case is the marker in my hand, to get a much better graph because I want to get a good estimate. So I'm going to get an asymptote of 7. I know it's exponential growth. And I know my first jump is 2. So I'm going to use the green to the orange. So that is now 2 units. And I know that I want to triple. So I'm going to get 6. So somewhere over here. 1, 2, 3. 1, 2, I think I'm here. 1, 2, that looks pretty good. So right there is an x value that's important. And I'm going up 1, 2, that's not too bad. So a 2 to 6 ratio is a 3-to-1 ratio, provided I find the right x values. All right, so 7 plus 2 is 9. And 7 plus 6 is 13. And these are going to be approximate answers. All righty. So I want a height of 19. And height of 19 is another 6 up. I think that's the height of 19. So I want this x coordinate, and I'm looking at it now. And I got to find the x's that go with these in order to guess that one. So what did we do in class? We picked a number 4. And that should get me 2 plus 7. Let's see if it does. 4 minus 4 is 0. That gives me 2e to the 0 plus 7, which is 2 times 1 plus 7. Yeah, that was the initial jump. That was the initial differential. Initial differential. And a differential is that bar right there. We call that a differential. The next one should be 13 if I pick the right number. Do you remember the right number? The right number is what makes the exponent 1.1. Because e to the 1.1 is 3, and I'm going to triple the size of this initial jump. So 5 times 1.1, 5.5 plus 4, 5.5, 9.4. Okay, so that's 4, that's 9. I'm going to say this is close to, I'm going to go 10.5 as a rough guess. I think something around 10.5 is going to get me 19. That's just a rough guess based on what I'm seeing here. That's a jump of 4. I think I went up maybe 1, maybe a little bit more than 1. Let's see how close I get. So my estimate graph 10.5, we'll come back and see just how close I was. So now we're going to get an exact answer. So the exact answer is solving this using inverse operations. Oh my God, I hope that was a 5. I've got no short-term memory. So what's our first step? 2e to the x minus 4 over 5 is equal, try to line up your equal signs, gives it a little bit, so that's 12. So therefore, e to the x minus 4 over 5 is equal to 6. And now the question is, do you remember where to go from there? So I mean, you said the right thing in class today. So we're looking for the value of this exponent. We need a logarithm. We need the special logarithm, the natural log, n for natural, L for log of 6. What am I going to do to that? Multiply by 5 and add 4. That's the exact answer. That's what I would take on a test. I'll also take an approximated answer, because if you give me a good approximated answer, I'm going to give you credit for knowing something that most people don't know. So our issue here is, what is the ln of 6? Well, we said 6 is equal to 2 times 3. We said 2 is approximately e to the 0.7. 3 is approximately e to the 1.1. It looks like 6 is equal to e to the 0.7 plus 1.1, which is 1.8. So this is 1.8 approximately. 5 times 1.8 plus 4 is 9 plus 4. Ooh, I don't like my graph. I thought I had a much better graph. I don't like being off by that much, but I will take 13 as an answer. It's in the ballpark. Close enough. I feel like that's a good enough, doing it from a different perspective. So that's the exact answer. Okay, now what did I want to show next? You know, what comes out of this is our rules of logarithms. So 6 is approximately e to the 1.8, we said. So let me bring that line of work down. So 6 is approximately e to the 1.8, and I'll write that on this side. And over here we had 2 times 3 was e to the 0.7 plus 1.1. There we go. Well, there's another name for 0.7. It's the ln of 2. There's another name for 1.1. It's the ln of 3. I know 1.8 is the ln of 6. Well, there's your first rule of logarithms. I could rewrite this as a single log, which means it's a simpler way of writing that. And we want to learn how to do that. When the world learned how to work with logarithms, they were founded by a Spanish nobleman named John Napier, and he published his work in 1619. And what that allowed people to do was work with huge quantities, because all you're dealing with here is the exponents. You want to get an answer to something, you got to put them on top of a base. And I think he did base 10 tables. And after he discovered that, there was this thing called the Enlightenment period. People like Kepler studying the universe, big distances between planets. And that calculation was as important back then as computers are to us now in terms of intellectual breakthroughs. Limited understanding on my part, but that's what I think was taking place. Okay. What else? Oh, yes, I also want you to make sure that you know how to get the inverse. And we just talked about the rules of logs. Oh, the domain and range. So what was the domain and range? I'll do that on the next problem for the e to the x. I got to do it now. Well, first off, I don't have to put the numbers in other than 7. Okay, so that's enough for domain and range. What x values can I use? Can I use that x value? Yeah, it's on the graph somewhere. That x value, yeah, it's on the graph somewhere. That, yes, this x value. So the domain is, you can use any x. Any x, so we can say all reals. You can communicate that to me by writing the letter R. So you can use any x number. There's no restrictions on this. But the range, oh, there's a restriction on the range. Every single one of these y values is positioned where? Above 7. So that's your domain and range. And the last thing we're going to do is the inverse, but I'm not going to do the inverse of the equation. I'm just going to do the inverse of this. All right, so let's get rid of that. Let's write this. Do you remember how to do inverses from class today? switch the x's and y's. So x equals 2e to the x minus 4 over 5 plus 7. And what did we say we could put in here? A 4 gets us 9, I believe. I think that's what we said. 4 gets us 9. So I'm going to make a calculation where up above here. A 4 gets us 9 up above here. So I want a calculation down here where a 9 produces a 4, where I switch the x's and y's, which is why I switched them. I switched them as of right now. So we want to solve for y. How do we do that? Inverse operations. And sometimes we call this, when we do it, an inverse function. So if you see that notation, it's all about this process. So I'm going to subtract 7. Try to line up your equal signs for organization. X minus 7, and I'll divide by 2. I think I can do both of those here. All right, and that gives me e to the y minus 4 over 5. We're right back to the same place we've been for several days now. How do you solve e to the? I hope the refrain in your head is ln of the. How do you solve an e to the equation? ln of. So I've got to do the ln of this statement. And that's going to get isolating the exponent. Remember, logarithms find exponents, and that's an exponent. So I'm going to do a little work here in a minute. Next 2 steps I think I can do. I'm running out of room. So I'm going to do the multiplication and the addition. So there's the multiplication, there's the addition, and there's my inverse function. Now we're going to put in a 9 and see if we get a 4. 9 minus 7 is 2. 2 divided by 2 is 1. We don't write the base, but it's base e. And the question is, e to the what gets you 1? That's a 0. Anytime you log 1, I don't care what the base is. Whatever the base is, what's the exponent on top of anything that gets you 1? 0. So 0 times 5 is 0, and I get 4. Oh, yay. Okay, it's not a formal check, but it's good enough for a test. All right, did I do all of the things I wanted to do? Yes. All right, so now let's do it again. 2 more times. And you pause the video and maybe try it, because it's going to be on your test on Tuesday and the following Tuesday and every week after that till the end of the semester, May. All right, so can you estimate a graphical solution? I'm going to try again. I'm very disappointed in my last attempt. 8e to the x over 5 plus 9 is a graph. You try to graph it. Equals 10. 10 is a graph. 10, 1, 2, 3, 4, 10, 10, 10, 10. So what is this? Y equals 10. Doesn't matter what the x is. All right, so let's graph the left side first. I'm just going to do it. You pause the video and try it. I see the constant. I see I'm above. I see a positive x. E to a positive x, growth. I am going to find 2 numbers here. And the 2 numbers are, make this 0. Make this 1.1. Because if I do that, I'm going to jump up 8 units. So I'm just going to write 8. And I'm going to estimate, because I didn't like my last one, 3 times that. I think that's going to be better. That's going to be 24. If I make this statement those exponents. So I'm going to put a 0 in. 0 divided by 5 is 0. I'm going to bring that back. E to the 0 is 1. 1 jump of 8 plus 9 is 17. Yes, this seems to be working out nicely. And 0 is what made that happen. If I put 1.1 in, that means Now, I'm not putting it in, I'm sorry, if I make it 1.1, looks like 5.5 is the number. That's going to be very helpful, because 5.5 divided by 5 is 1.1, and I think we've pretty much memorized that in a couple of days. I don't think, it's been 3 days maybe, and I'm starting to hear it all over the place, so that's 3 times 8. That is another jump of 24. On top of 9 gets me 33. All right, and now I want to be a height of 10. Woo! Height of 10 sounds like the Bruins scored a goal. Woo! So 10, I think, is over here. 10 is very close to 9. Maybe it's, ooh, I don't like my chances here. So if I cut that by third, a third of that is about here. That would be 8/3. On top of 9 is 2 more. I think I'm right about there. I'm going to take my, all right, taking my chances. Put my cards down. I'm calling you. Yep, let's see your cards. So that's 5.5 units from here to here. 5, 10. I'm going to say I'm near -10. So let's find out. So my guess, -10. Oh God, I have no faith in that. It's late in the day. I was in a fog earlier. Better get home before it even gets worse. No, we're not going to have fog tonight. All right, so let's find out how close I am. I think I'll subtract 9. I think I'll divide by 8. I think I'll undo e to the then I think I'll undo division by 5. That's the exact answer. Let's find out what that is. Let's find out what the ln of 1/8 is. So I guess I got to change, if this is base e, I got to write each of those numbers in base e. How could I write the number e1 in base e? I think it's e to the 0. How about 8? Well, 8 I know is 2 cubed, and I know 2 is e to the 0.7. So that's e to the 0.7 cubed. Okay, so what is e to the 0 over e to the 2.1? Sure looks like it's e to the 0 minus 2.1 in terms of the rules of logarithms. So it looks like it's minus 2.1. And I'm going to do 5 times minus 2.1, which is negative 10.5. I feel better. I feel better. Not a lot. I still wish I was closer. But I'll take it. Now, what are the rules of logarithms that come out of this? Well, I know 0 is another way of saying ln of 1. And I know I'm subtracting e to the 2.1, which is ln of 8. And I guess if I did that, I get the logarithm that gets me 1 over 8. I think there's a pattern here. Sure looks like I could simplify this that way, and it looks like I'm dividing. Oh yes, I started here, didn't I? I started with a division with all of this e to the. That's what's going on. All right, so subtraction of logs implies it comes from a division statement. Do we subtract exponents? Let's see. B to the 7 over b squared. Is that a subtraction of exponents? Of course it is. Okay, so subtraction translates into division. All right, you can tell I'm getting tired. The inverse. So now we got to do the inverse again, but not the inverse of the equation, just the inverse of the left-hand side of that equation, which is a exponential growth problem. I wonder what it's going to become. Thinking about the last problem. So we have a function here. I'm going to write it in functional notation. And I believe the original was that. Step 1, take it out. Oh, first off, step 1 is I'm asking you to find that. And I'm writing that because I want to communicate to you that that means we're doing the inverse of a bunch of operations. That's different than 5 to the -1. When you put a -1 above a number, that's reciprocation. When you put that symbol in front on top of the F, it means take the inverse of the calculation. So what's the first step? The first step is to rewrite f of x as y equals. To save time and energy, I'm going to switch the x's and the y's. So that's going to become an x, and that's going to become a y. And I think we could probably put a 5 in here. Now, what would be easy? Yeah, let's put a 5 in, that'll be fun. 5 divided by 5 is 1. E to the 1 is e, so I actually get 8e plus 9. So down here, I better get 8e plus 9 to become 5. That'll be fun. I haven't done that, so this is good for me. We're going to check that out. So what are the operations? Well, I'm going to subtract 9 and divide by 8. And that gives me e to the y over 5. Have you had enough reps yet to remember what you're supposed to do next? Thank you, John Napier. ln. That finds the value of this exponent. So I'm going to write it as y over 5 here. So now I'm going to put a 5 here, and that's my inverse function. And so now I'm going to evaluate 8e plus 9. I don't have much room, but I'm going to try to write 5 ln over here, and then extend this. And now I'm going to put for x 8e plus 9. 8e plus 9 divided by 8. Oh, I think I like it now. Because what happens to the 9s? They cancel. What happens to the 8s? They cancel. And now you're confronted with a new equation, a new evaluation. So I hope you pause the video there for a little bit and ask yourself, what's ln of e? Well, you got to know what ln stands for. What's the command? Well, logarithms, the value of the exponent that you put on top of, there's no base here. Oh, yes, it's understood to be e. What do I put on top of e to get e? I think the number 1. And what's 1 times 5? Oh, 5. I feel pretty confident that I did the right stuff. All right, now do we have rules of logarithms coming out of this? I think I did that. Yeah, we did division, yes. Okay, inverses. Oh yeah, we want to look at the range and domain from the last problem. What numbers can I put in there and put above 2.71? Anything I want. So x equals all reals. And then we had an exponential growth problem, and our asymptote was y equals 9. So what's the range of this function? If you can get something out, if you can get 9 or less, please show me how, because I don't know. I don't know how you're going to get anything other than answers that are bigger than 9 in this graph. If you can think of a way, show me. You're going to be famous. We'll put you in the textbooks. All right, so that's that. One more now. Okay, do you recognize e to the negative 0.7? And do you recognize e to the 0.7? E to the negative 0.7 is a half. If I put an exponent above it, that's decay. E to the 0.7 is 2. If I put an exponent above it, that's growth. Sure seems to me, if I have a negative exponent, I got a decay graph. If I got a positive x, growth, negative x, decay. So, next problem, doing the same thing we've done 3rd time in a row. If you need more practice graphing e to the x, I think I already posted that video. I think it's called speed graphing. So you go to my YouTube, Jim Vollinger and speed graphing, and it should pop up both e to the x and ln of x. We haven't done ln of x much yet. Touched base on it in one of the periods today, I think. All right, but we'll get there. We'll get there. So let's see, I already wrote these down so that they're nice answers. So let's do 4e to the 5 minus x plus 10 equals 18. We want to get an estimate graphically. And why am I having to do that? Because students coming into calculus don't know how to graph e to the x or ln of x, either one. let alone quadratics or anything else. If we practice every day, over time, I'm hoping you put it in your pocket. Any holes in my pocket? No, I'm good. All right, so I am going to sketch this side of the equation. I see y equals 10. I see everything is above it. Oh, I see a negative x. I think that's decay. So I think I've got an initial jump of 4. When's it going to triple? On this side. That seems 3 to 1 to me. If I find the right numbers. What's going to find me the right numbers? When the exponent equals 0 and when the exponent equals 1.1. Trying to write it slightly differently might resonate with someone. When is 5 minus x equals 0? When x is 5. When I put a 5 in, e to the 0 is 1 times 4 is a jump of 4 on top of 10 is 14. When is 5 minus x equal 1.1? I hate dividing by a negative, so I take positive 1.1. I like to move it to that side, and then subtraction of x on the left is addition on the right. That looks like 3.9 to me. And these are not exact answers, but 3.9 is going to get me pretty close to 22. So 3.9 away from 5 is 1.1. E to the 1.1 is 3. 3 times 4 is a jump, a differential of 12. Looks like a good graph to me. Now I'm trying to hit 18. You know, 18 is between 22 and 14. It's halfway between. Halfway looks to be right about there. Okay, so this x is 3.9. This x is 5, and I'm right about there. What do you think, folks? 4.2, 4.3? 4.3, I like 4.3. I like 4.31. I'm going after it. Let's find out. I'm going to go with 4.31. Let's solve it now. And I hope we can do domain and range right now as well. So what numbers can I put into 5 minus x? Anything you want. Goes forever left and right. But it only goes up from here. So the domain, I don't know why I did that, I'm tired. All reals, and the range, greater than 10. Okay, let's solve. 4.31, I'm going after it. All right. I think I'll subtract 10. I think I'll divide by 4. Oh yeah, isn't that such a nice number? E to the 5 minus x. How do I solve? Logarithms. 5 minus x equals ln of 2. So therefore, 5 minus the ln of 2 is equal to x. That's an exact answer. Now, the approximation is 5 minus 0.7. Oh, yeah, yeah. Whoa. I'm proud of that one. Oh, no. Oh, wait a minute. Yeah, no, 7.71 is the root 2 over 2. 0.7 here. Shucks. I was really debating whether to put that 1 there or not. I think root 2 over 2 got in my head. Now that's going to ruin my night. Oh, well, I tried. Anything else there new? So the other one we did briefly, I don't know if I did it in both classes, but you should have studied compound interest in your last class. I'm not going to show you where the formula comes from right now. I will at some point, I think, briefly, because you don't really need to know it. But P e to the RT A equals, used in money and banking a lot, where P is the principal, the initial amount of money you put in the bank. So let's say we put $50 in the bank. R is the interest rate, and they're pretty low right now. savings account when I was your age was 3 or 4%. Let's use 4%, which is 4 divided by 100. So 0.04, getting tired. T. And the question is, when do we get $100? When does it take? How much time does it take to double that? And the answer to these questions become a 5-second question after we learn the process, and that's going to take several days. Well, trying to double. If I'm trying to double, I do believe I want e to the 0.7. So the shortcut here is 0.7, which is the ln of 2, divided by 0.04, which is 0.7 divided by 0.04. And I'm going to multiply by 100 over 100 because it makes it so much easier. 100 means I'm moving the decimal 2 places. Decimal 2 places. Looks like 15 years, huh? It takes 15 years to double your money at a 4% interest rate in a savings account. It's nice to know that. If I wanted to triple my money, any idea what's going to happen if I want to triple my money? If you said, hey, ln of 3, you would have been right. And then it would have been not 100, but 110. Takes longer to triple your money than it does to double your money. Looks like it takes 22.5 years to triple your money. So we could play with this in all kinds of ways. So that's just another use of e to them. All righty. Did we do the last one with the rules of logs? Can't remember. Sorry, we're going to do a lot of repetition. We'll pick it up again. I don't even know if we did the inverse. So I'll do one more inverse. I'll just make up a new one. Maybe I did the inverse. I don't know. 5e to the x plus 2 over 9 plus 7. What's the inverse? The inverse is x. I'm going to subtract. I got to have more room. X. I'm going to subtract 7. I'm going to divide by 5. I'm going to multiply. I'm going to do e to the inverse of e to the is ln of. That's gone. Division by 9, multiplication by 9, addition to 2, subtraction of 2. And that's the inverse, just for practice. I'm going to graph those soon. Graph those just as fast as you graph the equation of a line. All right, so what else did I want to show you? I think that's it. All right, so you got three or four practices in there. And again, if you think about it, try it, and you don't get it, don't frown. This stuff takes time. Just go to sleep, get a fresh night of rest, come in the next day. A lot of times in math, in fact, being able to write the equation of those logs that I showed you, I don't know if I showed both periods, I spent months on that, thinking there's got to be an easy way to do this. And I figured it out in my sleep. I woke up at 4 in the morning. Oh, that's how you do it. So getting a night's sleep allows the brain to settle and get some energy and then come back at it. Einstein trying to figure something out. Last 20 years of his life, he never did. He never got it. Didn't stop trying. Kept thinking about it. Did a whole lot of other things well. All right, so I'm going to upload this to my channel and then put it on Canvas. And we will see you tomorrow with a worksheet, 50 problems. I'm going to go make that up at home, print it off tomorrow, and we're back at the board. Ta-ta.